R is a statistics program. It is bigger than Stata, Minitab, SPSS in that it has the complete set of statistics. It's free, it's a free download, and once downloaded it can work offline. So you may ask, where's the catch? Well, it's a program, not a package. When you download it, you will get something that looks like this, and you click at the prompt sign and you type in an instruction, and that instruction will then either produce the statistics you want here, or if you want a diagram, it will produce it as a JPEG here, which you can then transfer to your Word file. Anything produced here can be cut and copied into a Word file as well. So it achieves exactly what you would achieve with a package. Now, in this talk I'm going to try and keep it as short as possible, but it's really a distillation of the R I had to learn in order to write a paper, and I dumped all the instructions into a Word file, which is good practice, but afterwards I decided to make it up into this little booklet for other people who want to use R simply because Excel won't do the things that you want it to do, or won't do it in the right way, and so whatever statistic you want, it will be somewhere in R. What we do here is we go first of all to look at what R is, then we see how to create histograms, scattergrams and heat maps, regression, Cronbach's alpha for questionnaires, factor analysis, and then repeated tests, which I think is probably reasonably unique to R. And then we look briefly at errors, because you're typing a line in here and errors will come, and then final comment and further reading. So if we go to here, I'll get it to, there we are. I decided to jump to the end. This is a small convention I've got when you look at an instruction. I thought when looking at the books trying to learn R, well, what is the instruction and what is the name of the variable? Well, here I've given it a different color. So anything in green is the variable name, that's something you enter, and anything in red is part of an R command. And here I've not shown the prompt sign for R, which is here, which R the program puts in anyway. Right, and that's just a little look at the output that I was pointing to. How do you start with R? Well, let's have a closer look at this particular file, and maybe we can go just a little bit bigger. Okay, so this is how I work. I created a Word file where I put in my data, and I would make notes about the data, and it just generally served as a kind of rough work area. Then when I wanted to perform a test of something that didn't work so well in Excel, I needed to use R. So how do I get the data into R? Well, you do it like this. First of all, you create your data in Excel, and maybe download it from a database into Excel. So I kept it there. Then the data I wanted to use in R, I would block and paste into into something like Notepad or WordPad, or and then from there save it into a .txt file, a text file. I believe you can do that straight from Excel, but I don't know that you can do it without all the other notes. So Excel was my dirty work area. To enter data into R, it needs to be absolutely clean, and you want, in this case we've got two variables, Yumble and Zumble, and each variable is a column of data, and each row is a case. So the row 1 is an observation of 13 point, etc. for Yumble, and 0.4214 for Zumble, and that's case number 1. The columns must be on the same length. If data is missing, read in, or something wrong with it, then the R will tell you, and it will also tell you which line it is, and you go back to your Excel spreadsheet and find out what the line is, and no doubt it's something gone wrong. I had 45,000 rows, and therefore that could have been a problem. So R is pretty helpful in that respect. So you've got your data, downloaded it from a database, put it in Excel, you've then copied and pasted it into Notepad. You've got the name of your variables at the top using letters followed by numbers if you want to, and then you save the Notepad file into in the normal way into one of your folders. So that's created the data in a manner that is now readable by R. When the data is read in and you're operating R, it's going to look like this. This is what I said earlier. This is an example of the kind of program and instructions that you write, and the output is either going to come here or, as I said earlier, it's going to come there. So let's get on with reading the data into R, and you do that by this set command. And you can either take this command from the booklet here, well, you can take it from here, and then you paste it in here. At the end of your program, well, that's not going to work. At the end of your program, I would copy and paste all my instructions and dump it into a Word file. So I kept a copy of my past programs, and so if I wanted to start, I would go up and look up an old read table instruction and copy and paste it into R like that, and then I would change the file names, and that worked pretty well. And then if you forget all that, then you could go back to something like this and copy it from there. So this was a file I created earlier, as I say, and this is the block of numbers, sometimes called a data frame or a matrix. Crucial thing is that you the columns must be of the same length, and the variables are the columns and the cases are the rows. So if it was a questionnaire, the columns would be questions and the rows would be responses. If it does that, that means it's read the instruction and understood it. Having read in the file, we now need to attach it. Attach the file, so there's nothing special about the name. As I said, just it's best to keep to letters. So attach Fumble R means that you want to work on it. If you want to put it down, as it were, you would type in detach Fumble R, and that would detach it. It's always best to have different names for variables. If you do attach a file with the same variable names, it will blank out the previous one, so it's best to keep them the names different. So I attach the file, and now I want to, as you should do when you create any data, you simply want to summarize the data. So you just type in this, and it's called descriptives. And that's a descriptive. Now that's not terribly good, and in the leaflet I show you here how to improve on that. Now there's a package here which for the social sciences is quite a good one, and it's called Psych. Now what is a package? Well, what you've downloaded here is the basic R, and then in order to save space and so on, you can install packages written by various people. It's open source software. You can install a package which I would liken to kind of importing a bookcase, if you like, with lots of books in it that do different things. So we're going to, I don't need to do that here, but if you do it, it comes up with a lot of chatter here, so you don't worry about that. But I've already installed it on my system, so I just need to tell it that I need the book called Psych, and so I paste it in there, and it says, yep, okay, understood that. Now I'm going to do something that this book allows you to do, as it were, and I'm going to do it in a slightly roundabout way, because R often works like this, and this is slightly unusual to anyone who's done any programming. And here I create a variable that has the name of the variables in the file, and if you're doing that, if you're creating either numbers or names and putting them into a file, and that dash and that chevron and dash means put into, right? That's what it means, and that's the variable name that I'm putting it into. Note that it's in green, so you can give it what name you want. And the C is vital. It's, I think the Americans call it concatenate, which just means make a list of. So C, and then in brackets what variables you want to put in. So if I go click on here and go there, it says, yep, I've read it, and then I put in describe the variables in that. So we'll put that in. We now have the command describe, use the file fumble R, and the variables in variable bin. And here it gives you a more complete set of variables. Look at the mean, standard deviation, the median. Don't know what that is, so just exclude that. Mean, absolute deviation, minimum, maximum, skew, kurtosis, and standard error. So it's unlikely that you would want to have more than that as your descriptives. Now let's move on to histograms, very common thing to present. In this case, I'm going to have a histogram of Zumble. So I click that, and like that. Now, I have here a band putting all these numbers into this variable called band, that I've called band, and it's the same as before when we were looking at variable bin. These tell you the width of the variables at which one bin ends and another begins, and this band must cover the whole range. So if we go here, if we look at we can see the range here, that the minimum was for we're looking at Zumble, so the minimum was -15 and the maximum was 9.62. So -16 and 10 will cover the range. So -16 and 10 covers the range, and then I thought, well, we'll have gaps of 1. Now, if we go here, this is what it produced. From minus 15 to 10, it measured it out in gaps of 1. As is the way with, what am I doing? As is the way with R, if it doesn't like what you've put in, it will do its own thing. To illustrate this, I'm going to, get back into the right. It will do its own thing, so you don't have to define the breaks in it. There's an instruction here breaks equals band. In other words, take the divisions as defined in the variable called band. If you leave it out, it will make its own decision based on the algorithm that the programmer has used. The writers I call geeks, and they're pretty good at outlining something. But in this case, it's not terribly good, is it? Look, the outliers typically in this sort of thing squash the distribution. To improve it, I thought, well, I would quite like to see what is happening between -1 and +1. To do that, I create band 2 and -16, 16, I just forgot it was 10, but that will do. And then I went from -1 within that band to +1, going in steps of 0.1. In this case then, I'm going to enter band like that. I'll get rid of this. Enter band here. Go on. There we are. It's read that in, and then now I'm going to ask it to it like that. And note this is telling me now to use my breaks instruction. Like that. And that is now showing me a fuller picture of the distribution over the range that I specified. Notice that the histogram, I have to define that I want it to produce from -1 to 1 xlim, and it uses this again, this C instruction. You can also have ylim as well, which will restrict the presentation on the y-axis or extend it. So for example, here it's 2 and it clearly goes above 2, so if I put in ylim 0,3, it would include something for this, which is perhaps a little bit of a fault there. But ylim put in here as an extra instruction, 0,3 would then include the whole of the axis there, and I make that note clear there. We now have a better distribution and one that is of publishing standard. We've got the word density here, which means that it's the area that the area adds up to 1, which is perhaps not what you want. In this booklet I show you how to get rid of that, and you do it by something called subsetting. Now let's have a look at this instruction. It says put into a file called fumble3. Rows from the fumble are a file where Zumble is less than 1, sorry, where Zumble is greater than 1, original was okay, where Zumble was less than 1 and Zumble is greater than -1. So put in all the rows where Zumble has a value between -1 and 1. So you put that into Fumble, and then the next line, these lines are separate unless I say so. So with the next line you put with Fumble 3, do a histogram of the variable Zumble, and that will then create a very similar, if you compare the two, a very similar histogram, only here, I don't know if you can see that, but it says frequency. So I think we can probably have it a little bit bigger here. An important ability of R is to add lines at in a very precise way, and this is called the AB line for reasons that are made clear in the booklet, but I won't go into that. So the AB line I want to add is a vertical line read at at x-axis value of 0.19, and this is the median that is for the median for Zumble, and it's just the median, where's it gone? 0.19 here, that's why that's 0.19, and the mean is -0.09, and that is that one there. So I want to put them both into this histogram. I've hopefully, have I copied and pasted this? Well, I'll do it again. So Control C, and then click firmly here, Control V, and you can see that the median line is created there exactly where I want it, and then we do the same for this AB line, click firmly here, and that's that one. If we look at the instructions, here's the command. In the round brackets are the elements of the command. V is vertical line. If you wanted to create a line that is at an angle, then you would use the regression equation y equals a plus bx, and the a and the b you would put in as numbers here. So if you wanted to go through the origin at 45-degree line, it would be 0, 1, and so on. But if you just want a vertical line, it's going to be V. If you want a horizontal line, it would be H. Colour, there are various colours, red and blue, obviously. If you look on the manuals, which I'll show you how to do that later on, you will find a range of colours. Line width equals 2, and the line is the standard continuous line. Same for the blue line, line type equals 2, and 2 is a dotted line. Again, you can put in other numbers and see what it does, or look it up in one of the reference books. And there are PDFs that you can download for nothing. So we get a picture that is the same as this one, and again a pretty good histogram here. Personally, I'd like to see this a little bit higher, and we talked about Y-lim. So we've added lines. That's useful, and you can add lines to other the regression or scattergrams, and I would imagine heat maps as well. I've not done that for heat maps. This is an important attribute of R, which is very useful in presenting graphs. often you want to present some together, and you can do this using this function par_mfrow. I'm not going to actually operate that, but you can see what's happening. You put in this instruction and it says put into mfrow, it's got to be that name, equals C, and then in curly brackets 2 rows and 1 column. If you wanted 4, it would be 2 rows and 2 columns. If you wanted 6, it would be 3 rows and 2 columns, and 6 would fit nicely onto the page. So, I mean, it could be 2 rows and 3 columns if you want. So that's the row and that's the column. And it creates a kind of area like this, and then it just fits the graphs in one by one, going from top right across like reading. In this case, I've chosen to put in 2 instructions to create density lines rather than histograms, and the lines approximate what a histogram would look like. So we've got that, and I put in another one here. Looks exactly the same. What have I? Oh yeah, sorry, Yumble and Zumble. That prompt line shouldn't be there. You don't. That's part of the system, and it's one I've left out. And these are all separate lines. So you type in one, return another one, return, as I've been doing. Now, if we're looking at the relationship between 2 variables, in this case Zumble and Yumble, one way is to plot that. And to do that, we simply type the word plot, and in curly brackets there, and that's the outcome. We can see it's more frequent here, but we don't know what it looks like, that frequency, because it just turns black. One way of getting around this is to have something called a heat bin, where it gives shades according to the density. To do this, you need to install a package. That's another bookcase, if you like. We installed Cyc earlier. Now we install Hexbin. Having installed the bookcase, we now want a book from it called, unsurprisingly, Hexbin. So we type Hexbin, and then the next line is like that. Let me do that. I've already installed the package, so I don't need to do it again. It's installed on my machine, but it doesn't call it up immediately as standard, probably for operational reasons. And we put in that instruction, so that tells it go to that bookcase called Hexbin and pull out the book called Hexbin. To create the heat map, we need to type that, then we click here and press return. This creates our Hexbin. If we wanted to save that, what can we do? I think if we right click on, oh, it's not going to do it. No. Yes, we can go to File, which is just off your screen, and click on Copy to Clipboard as a bitmap, and then paste it into whatever document we want. Oh, shouldn't have done that. So we've got our heat map like that. Let's go back to here, and that gives what we were just looking at, a clearer picture. Now I ask the question, well, what is happening up here? Is there a ridge up here? but it's just too small to come into this picture. We therefore want to look at YUMBL values greater than 8. To do this, we take our subset function, which is like that. Click here, Control V, and that creates this subset and puts it into this file called Fumble2. It asks you at the end of a session whether you want to keep all these subfiles. It is always best to say no. There are plenty of places where you can save things, and to have yet another place is going to be confusing. So it is best to refuse that. You can always create it from the main file whenever you want it. Having created this file, you then enter this instruction, which is entered here, press return. Oh, I think I've forgotten something at the end here. Ah yes, I've forgotten a curly bracket because I didn't block it. Oh, let's go back to here. Curly bracket, where are you? There we are. The answer is yes, this ridge continues, as you can see, at a much reduced frequency compared to the original one. This process of subsetting, illustrated here, enables you to take the main file and select on whatever basis you want and put it into a subfile, and this is a much quicker process than in other packages. Not other packages, than in packages. This is not a package, it's a program. It does exactly what you tell it to do, which is quite a relief, having battled with some of the packages. Regression is a very common requirement in any analysis. Oh, I've got an error message there, but it didn't seem to affect our output, so we're not going to worry about that. We now want to run a regression, and the regression is like that. Here's the output. So it's y equals a plus bx kind of line. A, the intercept, is that value. The coefficient is that. It does not print out the actual result as an equation, which is a little bit disappointing. But just to read it out, it's this squiggly line means equals, as we have here. You would have to add it in, having pasted it into a Word file. But it is, to read it out, it's YUMBL equals 5.32 plus minus 0.18674 times ZUMBL plus the error term. As you can see here, there are high t values, but actually the r squared is low. Well, we won't worry about that, but that's the typical printout with some notion as to what the original equation should look like. But the actual equation I've put here, right, that's the one where putting our values in. So this A is the intercept, and B is the value, the coefficient for ZUMBL. Is that one. If you want to leave out the 0, then you put in this instruction. So there's no A in this one, right? A is equal to 0. So put that in, and it will come up with a very different. Oh, sorry. Right. Well, it should come up without the intercept, which it has done. What had I done wrong? I had put in a comma, and there shouldn't be a comma here, so that needs to be deleted, and it will be in anything I send out. That's the kind of thing that happens when you're programming. Errors are made, and you have to just take an educated guess. In this case, I knew it was -1. The only thing that was possibly uncertain as to whether it was a comma. Comma indicates a separation, which I thought would be there, but in this case it happens not to be there. And that is a bit the character of R. These things happen, and you have to just fiddle around a bit, and you almost always get there. If we wanted a more developed equation, multiple regression, this would be the instruction for this equation. So it creates the coefficients for each of the variables, adds in the the intercept, and obviously the error term. So that's an example of a more developed multiple regression equation. In this case, there didn't seem to be a positive relationship between the two, so I make a little note here. So, well, don't accept that. Let's create a subset of the value sumball between -0.5, where it's greater than -0.5 but less than 0.5, and then with that file we create a hex bin as we did before, only with this file rather than the original one, and we get a picture like this of a restricted view looking at it in detail, and you can see that this does indeed seem to be something of a positive relationship. But you have great flexibility when using these packages. This is Cronbach's Alpha. It's used in questionnaire studies. If you've asked a series of questions, I've got an example here of a database of 3 questions. These are the responses, these are the scores given. We want to know whether these 3 questions are moving in the same direction. So in this case, I imagine that these questions are about fitness, various aspects of fitness. It's a concept. You can't just ask a question, how fit are you? You need to ask them about their lifestyle and then make a judgment. So these 3 questions are kind of lifestyle type questions. You want to see if they're correlated with each other. You don't expect them all to be exactly the same, but you do expect them to roughly correlate with each other, and that is what Cronbach's Alpha is measuring. How do we measure it? Well, we first of all look around Google to find which site package it's in. There are lots of good help sites for you to look at, and then we discover that it's in the psych package. So we've already got that, so we just need to put in the instruction help psych. This then comes up, and we have one of the hyperlinks is to Alpha. We click on that and we get the Alpha instruction. We'll have a closer look at it. A little bit blurred there, but you can see the arguments for Alpha, the basic instruction there, and as you scroll down, there's an example here, Alpha, and then all the various instructions in constructing it. let's go back to 100. I've created a new table here, so I read it in, I give it a name, I then have to attach it, I then take out the library book at the psych and add in the instruction alpha, telling it to perform alpha on the file question RR. I could select certain of the variables from that file, in which case I'd put in a variable and we've got an example back up here where we put the variable names, if you remember, into a variable, and we would do that. Let's hope I can find it. Here it is. We put the actual variables into a variable bin. If we don't do that, it will analyze all the variables in the file, and in this case that's what we wanted. We analyze all the variables in question RR file. No, nothing special about the file names. The output looks like this. For those of you who know what alpha is, have read up about it or had instructions about it, you will understand what that is saying. Alpha has to be between 0.75 and about 0.9. In this case it's 0.82, so that makes it acceptable. We've got a 95% confidence interval here, and it seems to be kind of middle of the acceptable range. Then it tells you what the alpha would be if you dropped one of these questions. It would increase to 0.86. If question 1 were to be dropped, it would decrease to 0.56 if question 2 were to be dropped, and so on. I show you here where we only want, this is what I was looking at earlier, we only want 2 of our 3 variables. We're going to drop question 3. We create this file called bat, then tell alpha, using our file question RR, using the variables as listed in our bat file, which is Q1 and Q2. Those are the names of the questions that I've given up here on the notepad file. It then runs it again and tells me that the raw alpha would be 0.75, which is what we knew already, because if an item is dropped, if we dropped question 3, it already told us that it would be 0.75. Another more advanced analysis is factor analysis, and again I'm not going to explain what factor analysis is, but if you put in this, say use this file, and this is the number of factors to put in, and then on the next line you just put in PC and it will print out the results from that file. That PC file should be green, there's nothing special about that. Again, I won't be explaining exactly what's meant by factor analysis, but you may want help on that. You can do that if you click on if you put help psych package, then go to factor, and it will tell you what it will tell you about the factor analysis. The Varimax is a popular rotation to use. Again, this is in the instructions, it tells you rotate equals Varimax. and then just put in PC again, and it'll run it off with the Varimax rotation. Something that finally that R will do that other systems will not do, as far as I know, one is piecewise linear regression. It will perform repeated regressions, and that is effectively putting lots of little straight lines as we go along. Variables I've taken is of a new file, Yabba and Zaba, where y equals x squared, so Yabba equals Zaba squared. We first of all read in the file that I call square.txt, and I put it into an R file. I usually put a capital R at the end, you don't have to. And then tell it to attach the file. Been through that. I then give it a list of the row numbers for which, and put those numbers into a variable called k. And then I use the for instruction, similar to for instructions in other programs. So this is saying for every I in k, where I is just the next number selected, put into a file called fit a regression as so defined, and then you use the rows from the file square R, where the row is I, which is the next number. In this case, the first number we'll say is 100 minus 99, starting at that number, so starting at 1 to 100 for, and this is left blank, which just means all the columns. In this case is just one other column, but I can define the column by number. So if I put 2 there, it would, no, I'd need 1 and 2, so I need all the columns there, so I just leave it blank. And then print I, which tells me which of these numbers it's using, and then print fit, and fit is where the output from the regression is. So it will start off selecting 1 and do 1 to 100, then it'll select 2, take off 99, 101 to 200, rows 101 to 200, and then rows 201 to 300, and so on. And for each one it will produce a regression. So at a click of a finger you'll suddenly get a whole column of regression outputs. What do you do with it? How do you work it all together? What I did was, because I had to use this, I cut and pasted data into Excel. It puts it into one column, and then you sort on that column, and then you use the text to columns option in Excel and separate out the variable numbers. In that way all the coefficients will come together on the sort, and then when you it reads it as text to columns is the instruction. When you convert the column in the text into different columns and define the columns around the number you want, you then manage to isolate all the coefficients you want, and that is explained there. In this case the coefficients come out as all that lot, and if we plot it to the midpoint of our ranges, then we get a line like that, which is 2x, 5 and 10, which we know because that is the derivative of that. As I have illustrated, errors are quite common. You just have to accept it. It's probably why people have used packages rather than programs, but really there's no need for that, and the advantages of it being free and standalone makes it worthwhile to use. The error messages are rarely accurate, rarely clear, but they kind of just give you a clue, so it's a bit of a guessing game that goes on. Here we have line 2041 didn't have 6 elements, so there's something missing in the file. You've something object CO1 not found. You've forgotten to attach the file. That's something that's commonly done. Then couldn't find function ylim. Ylim's not a function, but it's trying to think it is. You've typed it in wrongly. Could be better, the error advice, but I don't know any program that does give particularly good error advice. Final comment and further reading. This is to say, don't waste time going into all the things that R can do. It is almost infinite. It is better just to stick to the basics and not use the developed options if it can be done in another way. As an example, adding labels to any of these histograms. It can be done in R. It's rather fiddly and complicated. Far better to cut and paste it into Excel, take off the grid lines, add in a text box on top of what you've just pasted, take a screenshot of that, trim it up, and you've got something that is exactly the same as if you had spent hours working out how to add a label to a graph. It's not worth it. If there are other ways of doing it, do it. If you have any problems, any comments, etc., here's my email address. Do email me and I will do my best to help you out. This is the Bible. It's pretty good, it's pretty clear, but these are all written by geeks, so that's why I've produced this. Shorter version that always seems to work, written by one of the authorities on the system. That's worthwhile. You can Google full reference manual and download that, and then finally there are the help functions in the R package, the R program. Right, so that is how you use R. I'm sorry it's taken so long, but I would hope that I have saved you hours and hours of either trying to find out how to do something, and which button to press and what the output means and things like that. I found in the end that it did save time. It's a tremendously powerful program and one that once learned you can keep.